In this session, I want to share about our automation journey. As you have seen, we love automation, we love high-tech machines, and we truly believe in Industry 4.0. But before I dive into that, I want to give you a brief introduction to our company, a little bit more of what we do. I think that is a good start for understanding why have we automated how we have automated. So we are high mix, low volume. We are specialists in high mix, low volume. So for us, very often we are only producing quantities of a batch can be 20 pieces, a batch can be 30 pieces. Some parts we are producing 100 pieces per year. So we produce many, many, many different jobs every day, every month. So we need to be super flexible. And that's also why we have automated in the way how we have automated, which I will share some more later. We are good in very complex machining, high quality CNC milling, CNC lathe, and wire EDM. And we are active in a lot of high precision industries. So from optical laser, semicon, analytical, medical, and production automation. We have implemented a lot of Industry 4 features, capabilities. But actually the funny thing is, it never started as wanting to implement Industry 4. What we wanted to invest in high-end machines, and we saw in order to make money with these machines, we need to automate. And then slowly we started to add the rest of the things to it. So we have automated, fully automated a robotized factory. We are simulating everything that goes to our factory. Most of the software is integrated, so most of the data flows from one piece of software to the next piece of software without anyone having to type it over or copying Excel sheets or any of that. And all the machines and all the equipment is with IoT capability. So we are collecting a lot of data, and at this moment we are ready to start to harvest that data and to do big data analysis on it. In this slide, I want to share you what we have. You can see our hardware in the factory, but actually it's a lot more than it's a lot more than the hardware that you see. Actually, most of the work in this Industry 4.0 is not in the hardware; it's in the software that is behind it. So it all starts with our ERP system. So the ERP system creates a job. That job goes to the CAM programmer, and the CAM programmer creates the CAM program. Then the CAM programmer simulates every program that he makes, so we can catch as many errors as we can in the office. That is first to protect our machines, so we don't have crashes, but also to find any mistake that we have made. This is all to get the maximum machine uptime. Then we have tool management. We have all our tool data in a Zoller tool management database. That is all the 3D models, but also all the cutting data. And this is used in our CAD/CAM, but this is also used for our tool presetting. And this data is also sent together with a tool to the machine. So this is a very important database for us. Then that goes to job management. As I shared earlier, we are high mix, low volume. So we have many, many different jobs. And with this job management, we have a lot of flexibility. So we can run in one night on the same machine different parts. And this job management software will plan that for us and will manage it all for us. Then let's go to the shop floor. We do our workpiece preparation. All our pellets have RFID chips, and all our workpiece offset is linked to that RFID chip. Then we go to tool loading. All our tools have a QR code. And all our tool data is linked to that QR code. So the tool offset, but not only the tool offset, but also parameters. Our tool life of that tool is tracked. Does the tool use true spindle coolant or not? And then that all goes to machining. We do all this because we want to machine. Before we start to machine, the robot loads the workpiece, the robot sends the NC code to the machine, and the robot loads the tools to the machine, but also sends the offset data and all those tool parameters to the machine. So all this goes automatically to the machine. And then in the machine, we can do quality control. So we can do probing inside the machine for the most important dimensions. And the rest we do quality control on our Zeiss CMM in our quality control department. When this process runs, we are generating a lot of data. And as I said just now, we are now far enough with the implementation that we can start to harvest this kind of data. The easiest is, of course, machine utilization. So we can see how often does the spindle run, how often is this machine working. But our target is to also capture the sensor data, so to be able to optimize our cutting parameters. We have many customers visiting us, and especially our European customers are every time asking us, why on earth do you invest in so much automation in Malaysia? Aren't you here because of the lower labor cost? Then we invest in this automation because we really see that it gives us benefit. This automation together with a 5-axis machine gives us a lot more capabilities. We can do 5-axis CNC milling, 9-axis mill turn, and these machines are very expensive. So my hourly rate on those machines is very expensive. And those machines have to run. If I have an operator in front of that machine, then I will never get that many running hours out of the machine as we now get with the robot. With an operator, if we get 4,000 hours per year, that's really, really good. If I put a robot in front of it, 5,000, 6,000 hours, we can get. Then we can actually make good money with these machines. Some of the parts we run on our 5-axis machine that in the past we would run on the 3-axis with many more setups, and actually it's more economical to do it on a 5-axis machine because I can run many more hours, but I need to run the hours. Our factory runs really 24/7. Reliability and efficiency, of course, that starts with our CAM simulation. And also the automation. With being less dependent on humans or less dependent on operators, I have less risk that someone doesn't come to work because he's sick, or someone resigns and I need to train a new operator. In all that time, my machine is down. Or we need to hire so many extra people that we always have spare capacity, which is also not economical. High precision and quality. So we have invested in high-end machines. Makino 5-axis CNC milling machine, DMG NTX 1000. These are high precision machines. We bought them with very many high precision options, purely for us to go up in that market, to be able to do higher precision parts, more complex parts, to talk to our customer, to also get that very complex very risky parts for our customers, to also produce that. And then the last one is risk mitigation. And I always notice that when I talk to people about automation, it's all about hours output. But if you ask me, our main reason, our first reason why we have this automation is to mitigate the risk. I'm just less dependent on an operator. My machine can run as long as I have someone who can set the machine and who comes in just to clean the machine and make the machine run. So I'm less dependent on people. Why we spend, for instance, so much time in our Zoller tool database, so our digital twin, is because a lot of the knowledge is suddenly captured in the database. In the past, before that, every programmer has its own set of cutting parameters. And every programmer has its own tool length that he wants, and everything is not stored. Now we have a fixed set of cutting parameters. If the cutting parameters don't work, we change it in the Zoller tool database, and the next time I make a program, I automatically have the right cutting parameters. So a lot more knowledge is stored in a database instead of in someone's head. As I said just now, already it is a lot less risk that someone is sick or someone leaves, so I have a lot of less attendance risk. And the last one, and that I find also very important, you see our environment looks good. We want to make this company attractive for people to work here, to retain the people that to retain the good people that we have, and to attract good people. And everybody loves to work with robots, and everybody loves to work with high-end machines in a high-end environment. So that is the last reason why we do this. We started this journey in 2018. We wanted to invest in high-end machines because we saw there was a market to do more complex things. And with the 3-axis machines that we had at that time, we couldn't service our existing customers that well, and we couldn't attract new customers that we wanted to attract. And the other thing is, we had a few very capable operators, very capable machinists leaving our company. Then we say, okay, this we have to solve. And with automation and with Industry 4, we can solve this. So, but we couldn't do this alone. We had a lot of ideas, but we needed partners. And that's where we started to work with OpenMind, Makino, Zoller, Erowa to implement this. And by working together with them, we became as successful as we are today. I've invited Simon from OpenMind and Samuel from Makino to later also share some things with you, because I want to continue with what challenges did we have, what lessons did we learn, but also what things did we do right. So I will first share some things that from our experience as Tonasco, and then I'll pass the mic to OpenMind and to Makino to share their point of view. So what we did right, absolutely right, is standardization. You cannot robotize if you don't standardize. So we standardized with everything is on a pallet. Everything is on an Erowa 0-point system. We only have the same type of vices. We only have the same type of tools. All our tool holders are standardized. Everything in our company is standardized. Without that, I cannot simulate. Without that, I cannot automate, because I don't know what's going to happen. Then, the next is, we started with one concept machine. So we bought a Makino D200 machine with one robot for pallet loading and one robot for tool loading. And we got the concept right first. That machine we got in 2019, and we have worked until 2022, till the next machines came in. So we really ironed out many of the problems. And some of the challenges that we had was actually our digital twin, our simulation, our Zoller tool database. We thought when we started, okay, maybe 6 months to fill that whole database. How difficult can it be? In the end, it took us 3 years to update all the 3D models, because we needed to get all the 3D models. All the 3D models that we got everywhere were not 100% right, or when we load them in, it gives problems. And so we spend a lot of time on that. Then we need to get the cutting parameters. Of course, I can get a cutting parameters from Seco or from others, but we still need to test those cutting parameters and make sure that what we load into our database is really optimized. That took a lot longer than we had expected. The last portion is employee involvement. We have from the start worked together with a small group of employees that were very involved. That went very well. I would say that we have done right. But now we have the following challenge. We need the rest of the company also need to get involved. And now we are really trying to figure out, well, how can we train the rest who has not been part of this journey for the last 5 years, but who steps in now and need to know all the knowledge that is in the head of our people that was part of the core team. And what we do realize is that this whole implementation, not only the digital twin, but everything, it takes a lot more time than I had expected. I think if I would do it again, I would probably get at least 2 or 3 engineers involved full time. Then we could go a lot faster and we can get all those benefits that we see a lot sooner. The last point we have is manpower. If you go on this journey, not just automation, but especially that integration and that whole Industry 4, you need to be ready to get higher level people and different skill sets. We already started in 2018 to hire a different kind of people, higher level people. And even today we see that we still have some issues, that certain staff are very good in this, but cannot cope so much with that. It's very complex what we have put. We see that we have to change our job scopes, rearrange who is doing what in this factory. So this is what I wanted to share. And yeah, I'm very curious what OpenMind has experienced during this journey together with us. So I pass the mic to Simon.
Thank you, Toon. Next slide, please. Okay, through this journey together as a supplier, OpenMind, and our customer, Tonasco, we have learned a lot as well. And these are the experience that, what are the challenges that we have experienced it. So first of all, it is about the mindset change. So what does it mean by this? Often, you know, in the beginning, these people, the programmers that Tonasco has, they are good programmers, honestly. They have used the previous software that they have. They are so quick, they can produce the NC programs, and they are a lot of more flexible to do however the toolpath they wanted to achieve. Yeah? But the setback is that a lot of time it is very much depending on the shop floor. They need to confirm and confirm again. So with this, it is taking time for them to do this, and importantly, it is very risky because there's no collision check on 2D program, yeah, with a 2D sketch. So therefore, we have gone through a lot of time to tell them that, okay, it is important to use 3D because with the 3D, including the tooling, yeah, this is why they are investing into the Zoller, Zoller to collect all the data of the tooling, and then it is to be used to check with the machine travel strokes and so on in order to find the correct travel stroke, and in the end also using a good machining strategy that come from this Hypermill that able to provide them with a very nice 5-axis simultaneous machining. So this is in order to drive their 5-axis machine from Makino machine. So this is what they are able to gain we spend so much time to debate why this is so important. In the beginning, they are just telling that their shop floor engineer, they would like to do the test, and then if this is not enough, they will manually prolong to make the tool longer or to make the tool shorter. So with this one, it is very, very dangerous. Yeah, very dangerous. Therefore, they also invested into our virtual machining, which is a so-called a digital twin, to confirm each movement, and also to give this kind of intelligence that the optimizer is able to decide when the tool is coming from this direction, it is unable to reach, then is there a second solution? So this optimizer is taking place to decide for the programmers. Therefore, the human decision is less. So everything put into the system to check for a better solution. Yeah? So this is about the digital twin that they can gain from this aspect. Yeah? So finally, going towards the goal to achieve in automations, then the job management is the next key thing. So to provide this information, OpenMinds also provide the important information so that this job management can be carry on to provide the information for the next process. Yeah, so this is where Makino come in.
Thank you, Simon. Samuel here from Makino. Thank you for this privilege to share about this automation journey. So I think Mr. Toon has already encapsulated a lot of the points from earlier very well in terms of how he standardized first and how he got his concept right first. So today, in terms of Makino's perspective, we will just share on 2 points. The first being automating the business processes before and after machining, and the second being a high-mix, low-volume environment that we're working together with Tonasco to realize. So on the first point about automating business processes is that what Tonasco experienced in terms of the time spent to standardize their processes and also to align everything and connect all the software together and to spend 3 years on digital twin, let's just say that this is hardly rare. It is hardly something that is unique to Tonasco alone. It's probably not. So in that sense, in terms of the automation journey, which also includes your process digitalization journey, this is something that inherently will take time. And if you look at it in terms of your own company, then essentially how you run your operation is like the DNA of your company, right? So you want to be on top of that. You don't want to leave that to a software that you have no control over. So here I will also like to do a shout out to Mr. Toon, because the other thing that he has done right, which he didn't mention, because he only mentioned his employees, he didn't mention himself. But actually he has been very, very hands-on from the beginning all the way until now, as we are learning together. To design and also to architect the whole system and how it's supposed to come together, so that all the different business partners that you see today, and in fact more than what we see today, are able to come together and the whole system works. So this is something like a case study that we're sharing today. So in that sense, let's keep it down to earth. A lot of buzzwords being named today, but does it work? So to be down to earth, yes, it works, because of the number of hours spent and also the architect over there, which also includes all the business process re-engineering that's gone through over the years. So the second point that I'd like to talk about is in terms of high mix, low volume. So the job nature in Tonasco is high mix and low volume basically. So we're talking about batch productions in very small quantities, but that does not mean that the accuracy requirement is any lower. In fact, if we're looking at the trend in the parts that we're talking about even today, the requirement for accuracy is only getting higher, and Tonasco has every intention to step up the game in terms of this accuracy requirement. So if you talk about automating tools, let's say, so you control your job, and in this case, the software does not just control the parts, does not just control machines. we control the process, and we also control the tools. So in that sense, when you load a tool, and it was used for job A, and you move over to job B, under such high mix conditions, how do you ensure the accuracy of the part that you produce in the end? It requires a lot of information and a lot of data from an earlier stage of the process chain that you can basically store and retrieve and implement in your next job. And this is also part and parcel of what I mentioned just now, which is what Mr. Toon has done to arrange the system in a way that this becomes something that is unmanned. Basically, this data just connects by itself, and we are able to manage this in a high-mix environment as well. So, looking back, these are probably the two challenges that were the hardest to address, but we're happy to have made the journey. We're happy to be where we are today, and I think that we both grown, not just Tonasco and Makino as well. We're happy to be a partner of Tonasco this whole time. Thank you.
Okay, thank you so much, and thanks for all the support during our journey. We share our journey because we hope to inspire other companies, inspire other people to go on the same journey. I personally, as Samuel said, I have been very involved because I find it just a lot of fun. I find it amazing what we can achieve in this journey, and I still see a lot of room for other things that we can implement besides what we have done so far. So thank you very much, and I pass it back to you, Catherine.